hadrosaurs to adults to determine if the young were physically capable of keeping up with a herd on the move.
They look hungry. What if they want to eat them?
Argued through a biomechanical analysis of the juvenile duck-billed dinosaurs that they were too young or too small to make any long-distance migration. So therefore, we argued that these animals lived here year-round. That opened up a whole bunch of interesting biological questions, like how did they survive the seasonality?
Tony's evidence has important implications for a long-running debate about dinosaur biology. Were they cold-blooded like lizards, or warm-blooded like mammals? Cold-blooded animals cannot long endure low temperatures. They seek external heat sources to power their metabolisms. Warm-blooded animals can generate heat internally to keep a constant body temperature. And many warm-blooded animals are found in cold climates. And there is strong evidence that dinosaurs were the ancestors of modern birds, which are also warm-blooded. But so far, no conclusive answer about dinosaurs. Kevin May's hadrosaur bone could add clarity to the debate. It's now in a lab in South Africa, where Professor Anyusha Chinsami-Turan is examining the bone for clues about dinosaur metabolism.
You're looking at a bone that is 70 million years old. What we see here are these interesting structures that tells us about how fast this bone formed, about the organization of the bone tissue.
The bones of warm-blooded and cold-blooded animals form differently. Reptile bones grow rapidly when conditions are favorable. But when food is scarce or temperatures drop, growth ceases. That start-stop pattern of development leaves telltale markings in the bone, similar to the rings in tree trunks.
These alternating rings of growth that we see in reptiles, they tell us that these animals, their growth is dependent on seasonality.
Birds and mammals, however, grow differently. They are not as sensitive to seasonal changes. They add new layers of cells more rapidly and continuously. In warm-blooded animals, no growth rings. Because the hadrosaur was a dinosaur, and because the poles experienced the most extreme seasonal swings on the planet, Anyusha expected that the bone would show pronounced growth rings. But instead, she had a surprise.
I don't see the growth rings that I would have expected in an animal that would have been affected by seasonal climatic conditions.
The hadrosaur bone more closely resembled the bone of a mammal or bird. That suggests that the hadrosaur did not hibernate or slow down during the winter. It was active all year round.
I suspect that perhaps this animal was very well adapted to the environment in which it lived.
For some scientists, thinking of dinosaurs as warm-blooded is the only explanation that makes sense.
If they're warm-blooded, you can see them surviving in this kind of climate, much as modern mammals and birds do in the Arctic today.
Today, biologists increasingly understand that there exist degrees of warm-bloodedness and cold-bloodedness in the animal world. It's not always one or another. Dinosaurs likely had their own unique solution to the body temperature problem, which allowed them to survive for millions of years in the toughest seasonal conditions their world had to offer. At the height of summer, the sun stays above the horizon nearly 24 hours a day. work has continued around the clock to clear the debris. Now is the time to find out if the bones buried inside are better preserved than those found in the cliff face. Kevin makes the most of the short time he has left. Jackhammers give way to precision instruments.
We have this frozen, unbroken matrix that we're able to shave off layer by layer, and it's not flaking apart. So you could not do this outside of the tunnel. You couldn't do it outside the permafrost.
Half of it broke. It's probably in here.
So now we get out the napkin.
Almost immediately, the team finds several extremely well-preserved bones, more delicate than any of the bones they found outside the tunnel. Kevin May suspects that they may be from a new species.
Well, it looks like we have two tail vertebrae and then a flat piece of rounded bone here.
It will take years to fully explore the tunnel and to complete the catalog of Arctic dinosaurs. To date, Tony's Pachyrhinosaurus skull remains one of the largest specimens to come from the Colville.
Yeah, it looks pretty good. It is busted up a little bit, so we'll have to keep our fingers crossed. But getting that stuff out of the way, you can really, this is really nicely defined now. I mean, that's a skull.
But despite its poor condition, the skull and all the other fossils miraculously preserved for 70 million years reveal a fascinating chapter in the history of the Earth. 230 million years ago, the Earth was even warmer than it was at the end of the age of dinosaurs. Those conditions fostered a great flowering of diversity, including the evolution of dozens of species which came to dominate the land, the air, the water, and eventually filled every corner of the globe. And then, 65 million years ago, a devastating blow to the planet. A massive asteroid impact. The prevailing theory is that the resulting explosion threw massive clouds of gas and ash into the air and plunged the Earth into a global winter. The theory held that dinosaurs, tropical animals, were unable to cope with the darkness and the cold that followed. But the discovery that dinosaurs already lived in non-tropical conditions and during long periods of darkness suggests that there must be more to the story.
I think that one of the values of our work is that it is suggesting that a catastrophic end to the Cretaceous did not kill off the dinosaurs.
But if the asteroid alone didn't wipe out all dinosaurs, what did? According to the fossil record, 70 million years ago, 5 million years before the impact, the number of dinosaur species around the world was already shrinking.
As we go through the late Cretaceous, diversity seems to decrease. And it's a general truism of evolution that the more biologically diverse you are, the more robust and able to cope with environmental change you are.
Before the asteroid, the writing may have already been on the wall. Continents were on the move. Air and water circulation patterns were changing, causing global temperatures to fall. The planet was slowly evolving into the world we know today, a world in which dinosaurs would not be able to thrive.
I think it's an instance where this huge impact that created the Chicxulub crater on the Yucatan Peninsula of Mexico was basically sort of almost the icing on the cake.
The fossil record cannot tell us how long dinosaurs survived after that terrible catastrophe. But Arctic dinosaurs, far removed from the disaster, could have been among the last survivors in their changing world.
No, really, on the 50, and that's it. We're done. Face the black.
On Nova's Arctic Dinosaurs website, watch any part of this program, go behind the scenes, and more. Find it on pbs.org. Major funding for Nova is provided by the following: ExxonMobil, taking on the world's toughest energy challenges. And by David H. Koch. And
discovering new knowledge. HHMI.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. Nova is a production of WGBH Boston.
I am PBS.